This is the first video in the AWS Developer Infrastructure series. In this video, we will set up code that will create an API gateway endpoint that will proxy a demo HTTP service. API gateway can be used to implement important design patterns like microservices, can be set up to allow flexibility for different types of clients, desktops, mobile, Internet of Things. API Gateway also provides a number of really important guarantees as regards performance and security. We have this URI, which implements a specific pattern, hits our gateway, then based on the attributes in the URI, gets mapped to various services. We have two types of maps. One is a HTTP map, then we have another type of mapping called proxy. We use the proxy mapping with AWS Lambda functions. In this video, we're just going to look at a very simple HTTP mapping where we will have a simple JSON backend that's provided by this service. When you hit this URL, it just returns nicely formatted JSON data. This view provides a low-level view of an API gateway request. First, we have our URI, which implements a scheme and has a payload. Method request, we have a chance to validate the data. For example, we could examine the headers for certain attributes that we may require. Similarly, in the method response, we can set up our data to be returned to the client. For example, we could add headers at this point and set the status code. In the integration request, this is where we proxy out to the service that will provide the response data. At the integration request point, we have an opportunity to transform the data with various tools, and at the integration response method, we can set up and package the data to pass through to the method response. Here is a snapshot view of the code. Here is a high-level overview of the code recipe. We're focusing here in this video on how we put the parts together, how we create the artifacts that can implement an API gateway rather than the simple demo code that the gateway runs. These names in yellow here correspond to functions that are called in that code block we just pointed you to. First, we need to create an API with a name, and that will return a REST API ID. Our URI will correspond to a schema where parts of the URI or path parts are mapped to a resource. The first path part we create is mapped to a base resource or the first resource, and then every subsequent follow-on path part we create is mapped to what we can think of as a child resource. In this example, we just create one path part, which is a base resource. Now we will implement the four basic blocks that we see here. We have functions that set up a method and its response, and integration and its integration response, with the input parameters you can see outlined here. Finally, we have a create deployment function, which takes all the artifacts we have previously constructed and then adds what's known as an API stage. This can be a little bit confusing, but if you just see how it works, it's a little bit more easier to understand. Once it's taken all the artifacts, added the stage, pushes the artifacts to AWS to create the API gateway endpoint. The code will also print out the test URI correctly formatted according to the schema, as we can see here. The first part of the URI is the REST API ID, which our code generates. And we have a standard Amazon path. Then we have our stage, which we discussed previously. So we can have our endpoint, which is composed of our resources, our base resource and child resources that we discussed previously. But they are prepended by a stage, and a stage is useful because we can have different stages for the same endpoints, and those different stages can be differentiated according to life cycles or project stages, such as testing. Now we will demonstrate running the code against Localstack. This is the test-driven development phase, then implementing the code on AWS with the API gateway, and we will monitor the code and clean up our test results on AWS with the AWS CLI. We will start by booting up Localstack, and we are running one service, API Gateway, for this test. So Docker compose up, we wait for Localstack to come up and confirm the services, and Localstack is listening and ready. Setting up its API Gateway endpoints, you can see Localstack and API Gateway are now ready. We will now use CLI in the terminal, setting the endpoint to point to Localstack. Check the status of any APIs that might exist in Localstack at this point. We expect to see none. So we run this command and we see there are no deployed APIs. So now we go to our Kotlin code. We find our deployments file. There's a main method where we can run the code that generates the artifacts and deploys to Localstack by setting this variable isLocalstackTest to be true. So we run this as a main class to deploy our gateway code to Localstack. Code is running. It's going to log some important information such as the REST API ID, and at the end it's going to print out the URI we would use if we were to run the URI against the deployed code on AWS. So this URI won't work with Localstack, but it will work with AWS. So now we've used Localstack to test that all our code doesn't have any bugs. It's going to work as we would want on AWS. This is very convenient for test-driven development. So we'll just confirm everything worked out in Localstack with the CLI, and then we will run the code again against AWS. We point the CLI to Localstack, run the get REST APIs command. Now we've confirmed everything worked out correctly inside Localstack. We're now in a position to reset our code, reset this variable to be false. Now we can run the same code against AWS. Localstack has really helped us a lot because we now know when it runs against AWS should work perfectly. So now we're running the code against AWS. Everything seems to be good. We have our final output here is the actual URI. So the code creates the URI with the REST API, the stage, and the resources correctly. We set up this endpoint to be a GET request, so we can just copy this URL into a browser for API Gateway to get the data from the JSON placeholder website. We set up our API Gateway endpoint to run off a GET verb or a GET request so it will work in a browser. So the gateway received our request and integrated the request to get the data from the JSON placeholder website and return the response. Our artifacts were set up correctly and it ran just as in Localstack. So now we can look in the console. We go to API Gateway in the AWS console. We can inspect our API Gateway we created, local HTTP test. We go to our methods. We're able to see the main artifacts we created programmatically, our method request and integration artifacts. We can select the integration request and we can see the endpoint URI. So when we hit the API Gateway, it's going to integrate this endpoint URI into the response, as we saw in the browser. So now we can clean up using the CLI. So we no longer point to the Localstack endpoint. We just use the CLI as it's set up and it will talk to AWS. So we find the delete API method. We need to add the correct REST API ID. So we have our API. So using the correct REST API ID, we can run the CLI to delete our API Gateway off AWS. Now when we refresh the console, all our artifacts that we've deployed to API Gateway should be gone. So everything has been cleaned up. We have no more artifacts. We have shown how you can set up a test-driven development workflow with Localstack for programmatically deploying artifacts to AWS to set up software as a service constructs like API Gateway. In the next video, we will show you how you can set up the Lambda proxy integration